Hello all, in this video we'll be discussing about Leetcode problem number 27, that is remove element. In this you are given an integer array nums and an integer value val, and you have to remove all occurrence of val in nums and that too in place. So let's see it in simpler terms. Here you will be given two inputs, that is nums array and val3, and this is in this specific case you have to remove all the occurrences of 3 from this, and the remaining elements are 2, so that's why the output is 2, and also you have to arrange these 2 at initial place in nums. So the observation says, first of all, the solution must be in place. The second, the order of the k elements does not matter, so irrespective of the order you can just propose a solution according to that. The third is elements after k also does not matter, since they will be only picking up the first k elements. So the obvious solution that comes to the mind is that we can initialize two variables I and j initialized at 0 index. So what will be I doing? I'll be traversing the complete array, and j will be keeping track of all the elements that are not having a value of val. In this case it is 2. So what I'll be doing is, if we encounter an element that is not equal to val, I'll be copying the ith value at jth position. Otherwise, if I encounter a value of 2 that is value equal to val, so I'll be ignoring that, I'll be just incrementing I. So let's take the steps now. Since 0 is not equal to 2, so I'll be overwriting it and keeping it at jth position and incrementing I and j both. Again, a value not equal to 2 is encountered, so again I'll be overwriting it and keeping it at jth position. Again I and j will be incremented. Now I have encountered a value that is equal to 2, so I'll be ignoring it. I'll not be incrementing anything in j, I'll be only incrementing I in this case. Again 2 is encountered, so ignore. Again, in the next step, 3 is encountered, which is not equal to 2. So I'll be overwriting the jth value now. I'll keep keeping 3 here, and I'll be incrementing j. Now again a 2 is encountered, so ignore. Again a 2 is encountered, ignore. Now a 5 is encountered, so at jth position I'll be overwriting it as 5. I'll be incrementing j. Now since the end of the pass is encountered, so now we'll be returning j at the index, and it is having a value of 0, 1, 2, 3, 4. So 4 will be returned, representing that there are 4 elements that are not having a value of 2. So this is a very fine solution, but it takes care of the relative ordering. But as per the question, you can see that order of k elements does not matter. So can there be any solution which is not, which is just carefree regarding the sequence of ordering, but also releases the overhead of copying the values at each and every step? So can there be any solution which can just reduce this overhead of copying values? Then yes. And it is only possible to do this observation. Keep it in mind, order of k elements does not matter. So with this we can propose a new solution. Here also we are taking two variables. One is, as earlier, I, which I'll be initializing from 0th index, and I'll be using it for traversing. And the second is n, which is basically maintaining the number of elements being considered. Okay, so as of now, since these are 8 elements, so n is initialized to 8 at the starting. Now what I'll be doing in this is, if a value not equal to val is encountered, then I'll be incrementing I. Otherwise, if a value equal to 2 is encountered, then I'll be picking up a value from the last and replacing it with that value, and I'll be decrementing my n. So let's go ahead with the algorithm. Since it is not equal to 2, I'll be just incrementing I. Again, it is not equal to 2, so I'll be incrementing I. But now here I have encountered a value of 2. So what I'll be doing? I'll be picking an element from last, that is n minus 1th index, since the index is starting from 0, right? So I'm picking up the element from last. I am keeping it here, and I am decrementing by n by 1. So now n is 7. Now again I'll be looking over 5. It is not equal to 2, so I can increment I now. But now again I have encountered a 2, so I'll be stopping here. I'll be picking an element from last. I'll be decrementing a value of n and I'll be replacing it with 2. But again, if I consider it in the next step, it is again a 2, right? So again I'll be replacing it with nth value, right? I'll be decrementing n and I'll be using that. Now again I can see it is again a 2. So again I'll be picking an element from the last. I'll be decrementing n and I'll be placing it. So now you can see it is now the end of the pass. All the elements are covered, and in this way we'll be returning 4 at the end, which states that only 4 elements are there which are not having a value equal to val. So now let's see how we can code this. It is simpler, where I is initialized to 0, n is initialized to num size, and here while I is less than n, this was the only loop till I is less than n, and you can just see here I is equal to n in this case, so the loop has terminated now. So while I is less than n, if num size equal to value, then you have to pick up element from the last and you have to place it at ith position, as well as you have to decrement n in this step. Otherwise, if it is not equal, then you have to increment I. So in this way, you will be considering each and every element, and even you will be considering the replaced element as well. So by the end of this loop, it will just make sure that all the initial elements which are not having value equal to 2 are placed initially. So this is how you will be returning n, that is number of elements in nums which are not equal to val. So that's all. Thank you for watching. Have a nice day.